Hi and welcome to the videos for section 12.6 for Math 126. In this chapter or section, we're going to be looking at what is known as the binomial theorem. So, we'll actually get to the theorem in video 3. But to get there, we need to set some groundwork as to processes and formulas that we're going to be using for the binomial theorem. So first, let's look at the following. If I have the binomial term, so bi meaning two terms raised to the first power, this is what? This is A plus B. If I have A plus B squared, so if I had to FOIL this, if I FOILed it, I would get A squared plus 2AB plus B squared. If I did A plus B to the third power, so A plus B times A plus B, I FOIL that, and then I multiply it by A plus B again, I would end up with A to the third power plus 3A squared B plus 3AB squared plus B to the third power. Let's do one more. If I had A plus B to the fourth, and you FOIL this guy over and over and over again, you would get A to the fourth plus 4A to the third B plus 6A squared B squared plus 4AB to the third plus B to the fourth. So again, if you have free time, you just want to do some more math, feel free to FOIL that whole thing out, see if you get it, but that's what you would get. So let's look at what's happening here. So notice, for a general binomial A plus B to the nth power. So for the first one, we have the first, it raised to the first power, how many terms do we have? 1, 2. When we were raised to the second term, how many terms? 1, 2, 3. So we had 3 terms, 2. How many here? 1, 2, 3, 4, 4 to 3. So the first thing we see is what? There are n plus 1 terms. So if my n power here is 10, if I multiplied it all out, I'd have 11 terms. Next thing, what do I see? Well, I start with A is 2, then A is 1, then A is 0. Actually, let's go to the third here. So A is 3, A is 2, A is 1, A is 0. How about B? B is 0, B is 1, B is 2, B is 3. So the second thing we notice is that the exponents for A decrease by 1 with each term, and the exponents for B increase by 1 for each term. And then lastly, again, let's look here. So this is what? This is like B to the 0 power. This is like A to the 0 power. Anything to the 0 power is 1, so we don't write it out. But we have what? 4 plus 0 is 4. 3 plus 1 is 4. 2 plus 2 is 4. 1 plus 3 is 4. 0 plus 4 is 4. So the sum of the exponents is equal to n. So whatever my power is that I'm raising this to, all of the exponents, if I add them up for each term, should be equal to that value n. So that's how we can figure out information for the exponents. How many terms are there? What should the exponents be for the variables? But what about the coefficients? I had 1, 2, and 1. I have 1, 4, 6, 4, 1. Is there a shortcut for that? Well, let's not write, let me do this first. So let's do one more. Let's go back up. A plus b to the 0 power. Anything to the 0 power is what? It's 1, right? All right, so if all I do, I'm not going to write the variables, I'm just going to write the coefficients. I have what? I have 1 for the first line, and then 1, 1 for the second line. What's the third line? 1, 2, and 1. How about a plus b to the third? I have 1, and then 3, and then 3, and then 1. So let's take a look at this. What are we noticing here? First off, I have 1s all down the outside. How about the middle numbers? Well, 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. So if I don't even look at the fourth row, if I just use this logic, I should get what? I should have a 1 here. If I add these two, 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And again, a 1 down the outside. Let's look back here. 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. And that'll go on to infinity. And this is what's known as Pascal's triangle. Too much EDC on my mind. Pascal Rotel. It's not him. He didn't come up with this. He came up with some other stuff. Pascal's triangle is this idea that the coefficients form this triangle, and it has this property, 1 down the outside, and you can add the coefficient. So without even writing what the fifth one should be, it should be what? 1, 5, 10, 10, 5, 1. And I could figure out the terms because I have what? A to, if it's to the fifth power, a to the fifth. And then a goes down 1, that would be 4, b goes up 1. A goes down 1, that's 3. I know they have to sum up to 5, so b squared. And then a to the squared, b to the third. And then 5a, b to the fourth. And then lastly, b to the fifth. So I don't have to do any of that long math anymore. I just know based off of the general idea in Pascal's triangle, a plus b to the fifth is this guy. So that's it. That's video 1. Pretty short, concise, kind of looking at some binomials raised to a power. How would it expand? What's some general information we can pull from it? And then how can we find the coefficients for the different terms? So although this is useful for our small values of n, you can see already that with a plus b to the fifth, it gets pretty big. What if we have a large number, a to the 100th or something like that? Can't really use Pascal's triangle. That we're going to tackle in video 2. That's the binomial coefficient. So come on back and we'll look at that. And then finally in video 3 we'll get to our binomial theorem.